now we will carry on our example and about static aeroelasticity, forces on airfoil. So now we have this airfoil and the forces acting on the airfoil. So you see here the negative gauge pressure, which is vacuum, and this is the shear stress. This is the positive gauge pressure, okay? And this is the configuration of the forces acting on the airfoil. So F sub L, V naught, F sub D, which is the drag, and these forces on the bottom of the airfoil, which can be analyzed like shown in this, as shown in this triangle, force triangle. Okay, you see this one is the aeroelasticity for airfoil. So this one is the airfoil, and these are the forces acting on this one. Okay, now before we continue our discussion about the airfoil, we need to consider one point from our past study, which is the shear center. Okay, the shear center, because the airfoil is a thin structure, thin-walled structure, like what I show here, and these are the forces on this thin-walled structure. One of the points to be discussed in airfoil and in thin-walled structure is the shear center. So the shear center will be explained in these figures. This is a thin-walled structure, thin-walled beam structure, and if it is acted on by this force, then there will be a shear flow. You see the shear flow. This shear flow will determine the location of the shear center. So the shear center is the point at which the vertical load is exerted so as not to produce any torsion. Now, if the total F is the integration of the Q, the shear flow, which is called the shear flow, ds is the length of infinitesimal element, and it is from A to B. So now this force is this part. For this part, we will integrate for this part. V is equal to QDS, and it is from D to B. So it is about this one. And E will be, which is the eccentricity or the location of shear center, will be, which is this distance. It is the distance at which the force is applied so as not to produce any torsion. So now E will be computed from this equation. We explained all this one fully in the last session. Now today we will go through and we will check this example. You see, this example, in this example, we will know how to calculate the value of E, for this section. So this section with these dimensions, the E, or the eccentricity, or the shear center, is located E 1.6 from the web. We will now know how to calculate this E. Okay. Number one, the first step here is to calculate tau. We explained this equation before, which is Q over T, and then it may be written like this: Q V over I T, where Q is the static moment of area, V is the vertical force, and I is the moment of inertia of the whole section about is centroid, and T is the thickness. T is the thickness of this section at any point of consideration. So now This can maybe also written as VH to IS. We saw this relation in previous lecture and how we can conclude this one from QV over IT. Now, tau sub B